Okay, so lesson 3.5, I have a video going over some similar examples to this. Check that out later if you wish, or not, your call. We're still playing around with mathematical expressions. Those expressions are lines. We have that y equals mx plus b equation we've been beating the heck out of for the last couple of weeks here. We have the slope formula that we've been getting better at, the rate of change formula. We're going to take it up a notch. So the previous problems we worked with, we had to calculate the slope, but we were just given the number for b. It was just a number that was given. We didn't have to do anything special to find it. Now we're going to look at problems where we don't know what that initial value is, and we got to figure it out. So that's how things are getting a little harder. There's a simple example of doing that here, which I encourage you to look through on your own time. So I'm going to do one of these with you right now. So let's take a look at my question 1. Let's put it into my magic whiteboard. So we want to find the equation of a line through the points 15, 8, and 25, 6. Now, if the numbers are relatively simple, I like to try and sketch them. What does that mean? It means plot the points. If the numbers are a bit more complicated and I'm not sure how to draw it, then I really don't need to worry about it. But I'm going to do a rough sketch of this to see what's going on. So let's see, they're all positive. X is going from 15 to 25, Y is going from 8 to 6. So rough sketch, since they're all positive, I only need to draw this upper right part of the grid. And for X, maybe I'll scale by 5, 10, 15, 20, 25, and I want those 5s to be as equally spaced as I can make them. Okay, I'll catch you later, Samuel. Take care. And then here, I got to get 8 and 6 in there. So maybe I'll scale those by 2. So like 2, 4, 6, 8. All right. And again, remember these always come in the form X and then Y. It's always the horizontal variable first and the vertical variable second. We also call those independent variable, dependent variable. Sometimes we call them input and output. Lots of different ways to refer to them. Output, there we go. So let's see, 15, 8. So 15 goes with 8, so that's here-ish. And then 25 goes with 6, so that's roughly right there. And I want to find the line, equation of the line that goes through those points. And I can kind of backtrack back through there, and I can kind of guess what that y-intercept is. So if I just go back and guess here, let's see, 2, 4, 6, 8, 10, 12, 14-ish, maybe 14-ish. It's not a real number, but something like that. All right, so again, if I did a good graph, I can put a ruler down. If I don't have a ruler, I get a piece of paper, fold it in half, or grab an envelope, use that as my ruler. So improvise, do good math. So we know how to find the slope. We've been doing that for days and days now. That's our y2 minus y1 over x2 minus x1. So let's see, y2, that's going to be my 6. Y1 is my 8. Since I started with 6 for y, I got to start with 25 for x, and then minus 15. So remember, what's important about the slope? Y is going the top, x is going the bottom, and the points line up vertically. So double check that when you write these down. Every once in a while, I do one backwards, and that throws everything apart. Okay, 6 take away 8. Had 6, lost 8. That's bad. I'm down 2. 25 minus 15, that is positive 10. I'm getting a negative slope. Is that reasonable based on my picture? Answer is, yeah, that goes downhill, right? Downhill should be a negative slope. So this matches. And I could reduce that. 2 goes into 10, so I could say it's negative 1/5. Or if you whip out your calculator, you should get negative 0.2. Sometimes the decimals come out nice, sometimes they don't. So we have a bunch of different versions of the slope. This is pretty nice. I like that guy right there. All right, so I was told to find the equation of a line. What's the equation of a line look like? Well, it looks like y equals mx plus b. I just calculated my m there. B, remember that's our y-intercept. We also call it the starting value or initial value. Starting value. And I wasn't given that. I mean, I can kind of guess it's somewhere in that vicinity. Are my points plotted perfectly? Is my line drawn perfectly? Are my axes scaled perfectly? No, no, no. So I'm guessing it's 14-ish, but I don't know. All right, so here's how we find it. Pick a point. I like that point. And we know the slope. So what we're going to do is we're just going to plug our point in here, x and y, and we're going to plug our slope in, and then we'll figure out b. It doesn't matter which point you pick. So my y value I'm picking is y equals 8. My m I just calculated is negative 0.2, and the x value for my point is 15. So times 15. And look, I can find b, it's the only thing left. So to find b, I got to do my multiplication. What's 0.2 times negative 0.2 times 15? I'm guessing it's negative 3, but a calculator is a good idea. So negative, ooh, clear, negative 0.2 times 15. Hey, I got it right. Cool. My day is getting better. All right, so that right there comes out to be negative 3. And so to get b, I'm just going to bring that over to the other side. Since I'm adding a negative number here, we're going to add the positive version of it to cancel, right? Negative 3 plus 3 is 0. We do a plus 3 on the other side, 8, 9, 10, 11. Ooh, I was way off in my picture. It looks like b is 11. Let's see. So 2, 4, 6, 8, 10, 8, 15. Oh, I can't even draw straight lines today. Okay, so something's wrong in my picture there, or something's wrong in my calculation. What could it be? Well, let's troubleshoot some more. I think the equation at this point is y equals negative 0.2x plus 11. Okay, if that's true, I should be able to plug in this x value and that y value, and I should get the corresponding y value back. Well, let's check them both. What happens if I plug in 15 here? Let's see, if I plug in x equals 15, then I get y equals negative 0.2 times 15 plus 11. We already calculated that negative 0.2 times 15 is negative 3. 11 minus 3 is 8, which is what I wanted it to be. Okay, that's a good sign, good sign. Good sign. Let's check the other one. What if we let x equal 25? Then we think y should be negative 0.2 times 25 plus 11. Okay, 0.2 times 25, what is that? I'm gonna guess that's negative 5, I'm not sure. Clear. Negative 0.2 times 25. Man, I'm on a roll. Cool. All right, it is. And what's negative 5 plus 11? That'd be 11 minus 5. That's 6. Hey, that's a good thing. Okay, so something was wrong with my picture. It wasn't very accurate, but it did tell me the slope was downhill. That was a good thing, right? So now I have an equation. The line that goes through those 2 points would be y equals negative 0.2x plus 11. Circle it, exclamation point it, job. All right, so what just happened here? Summary. To find a line through 2 points, two with a W. There we go. points. There we go. We find the slope first. That's step one. y2 minus y1 over x2 minus x1. That gets us partway to the answer. To find b, second step, solve for b, y equals mx plus b. And the key here is that this y and that x there are one of the points. Doesn't matter which point. Okay. I could have picked the other point back on that problem before. So just testing this out, I had found m for that other problem was, let's see, 6 minus 8 over 25 minus 15. That gave me negative 2 over 10, which we reduced down to negative 0.2. Now this time I'm going to pick the other point to plug in. So I'm going to plug in, let's see, what did I do? Last time I plugged in the point 15.8. So watch what happens if I instead plug in the point 25.6. So y equals mx plus b for step 2 here. And then now I'm saying y is 6, negative 0.2 times 25 plus b. So we fill in our point and our slope and solve for b. So we figured that was negative 5 earlier, plus b equals 6. So we would then add that 5 over to the other side to balance things out. That goes away, leaving just the b is 11. Look, I get the 11 no matter which point I picked. The only time those two won't exactly match is if you did some rounding on the slope, then you'll get slightly different versions of b because of your rounding. So rounding can throw these off a little bit, but they should be pretty darn close if you if you round carefully. So this section is more about, okay, so suppose we're given some information we don't know b the starting value. Is it possible to figure it out? And the answer is yeah, we can figure it out. So let's look at a more interesting problem. All right, what do we got? We got the problem with Raj's weight loss. So that was presented in the last lesson. And we didn't find an equation for Raj last time, but now we can, because we can take these 2 points and find the slope. And then based on these 2 points, we can find his starting weight, even though we don't know it at the moment. Same process we just did a moment ago. I'm going to skip that one and let you do it. So we'll come back to that. Next page here, we're going to take some data about minimum wage in Washington State. And so that's presented here both as a table and as a graph. And we're going to pick 2 points in this graph to find a line that goes through them. And when we do problems like this, you can't just randomly pick 2 points, and I want to show you why. So I'm going to take a screenshot of this so I can scribble on it. So we have to be deliberate about our point choice. Let's grab all that. So I want to find a line through these points here. Now the points don't perfectly line up, but when I squint, they make a pretty decent line, right? It's not too bad. It's like me trying to draw a line on a straight line on my whiteboard with the freehand pencil here, right? Sometimes my line's a little bit wiggly, but I can always use the straight tool to straighten it out, right? So these points are more like this line up here. There's a little bit of wiggle, but they're they line up pretty good. So we can find an equation that fits these by picking 2 points to make the line pass through. Because once we pick 2 points, we know how to find the equation of a line through 2 points. Now, maybe I could pick the first point and the last point. So I'm going to try that. So if I try connecting those two, what I want to have happen is I want to have just about as many points above the line as below the line. And when I look at this right here, it seems like there's more action going on above than below. So I think my line's a little bit too low. So And I kind of missed that last point. It looks like more I did like the first point and the second to last point. So this line, I think, needs to go up just a little bit. So I'm going to grab it and try to move it up. And so I want to put it in a place where, and is even that the best slope? I don't know, we could tilt it a little bit. But here I'm trying to put it in a place where there's just about as many points through the line as above it as below it. Maybe that's a touch too high, maybe it's not. So looking at this particular line right here, I might guess that, let's say this point right here seems to be right dead on there, and maybe this point right here would be a good choice. So that would be what? 2007 I might pick as one point, and what's this one? 2012 I might pick as my other point. And just like we did that previous problem, if we know x, y, x, y, we can find m and b. All right, now before we do that, I just want to point out where things can go bad. So let's undo some of this. There we go. You can't just pick any 2 points. Sometimes the first and the last are good choice, sometimes they're not. Here's a very bad choice. If I tried to make a line go through this point and that point right there, so let's make that my line. Does that line fit the trend you see there? The answer is no, that line's way too steep. Overall, the trend of these points is more shallow. So this would be a bad choice for the 2 points to pick. So we would not pick what, 2008 and 2009, that would be bad. And it could be you pick 2 points that go in a much worse direction. Check this out. Suppose I picked, let's see, is there a good choice here for something really bad? Good choice for something really bad. Sort of. I'm going to go for, let's say, these two, this point there and that point there. That is kind of a flat line. Do these things flat line? Are they always the same? Oops, I want my pointer tool. Slide that over. The answer is nah. Come here. I want you. There you go. Right. That would be a bad choice too. And every once in a while, points in life, sometimes they go up, 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 but sometimes there's a little bitty dip. And it's possible you could pick 2 points that go in a negative direction when really, on average, things go in a positive direction. What's the point? The point is you can't just randomly pick 2 points. You got to be deliberate about it. And you want to end up with 2 points that show the general trend. There's about as many points hitting the line and above the line and below the line. I'll come back to that in a minute, Caden. All right, so let's get rid of that here and look back at this problem. Show the problem. Okay, so we're given this data right here. We got a video example to go with it. You can check that out later. And then we're asked, each of the following lines was found using a pair of points from that data up there, but some of these are a good choice and some of them are a bad choice. Now I picked those 2. I'm gonna undo that. Why did I pick those 2? So again, what I want when I draw a line through these points is I want the line to fit the trend, to be about as steep as the average steepness of the points. And I want about as many points above the line as below the line. I want to kind of split the difference there. And with this one right here at the top, there's way too many points below and really nothing above. This one kind of does the reverse. This one, there's too many points below and really not much going on above. But this line right here has some balance to it. This one's way above. There's a few that are just a little below. Same thing down here. This one's kind of a little bit above and the others are kind of a little bit below or right on. So these 2, I think, do a good job of representing the trend of these points, but these 2 don't up there. So that's why I made that choice. Now what we want to do, now here I'm telling you which points to pick. Sometimes I'm going to leave it up to you. If I leave it up to you, then you have to carefully look at this. Often what I'll do is I'll take a piece of paper and hold it up to the screen and use the edge of the paper to figure out which 2 points to pick if someone doesn't tell me. For this one, I'm just going to tell you. So here, we want to use data from values 2005 and 2015 to get W, the minimum wage, and T is the year after 2000. All right, so let's put that together with the problem we have above. Screenshot that question. All right, so here's my question. Okay, so isolate some data here. Use the data from values 2005. So I'm going to circle that one. So I want this here. And 2015. Okay, so they're saying, hey, use the first and the last. Okie doke. Those are the ones I'm going to use. W is what I'm going to use instead of a Y. And T isn't the year, but it's years after 2000. So I'm going to add a new row up here for T. And T again is years after 2000. And I'll explain why we do that in a minute, but we'll often do that when we're talking about real years, like this year, 2021, and past years that aren't too far past. So this would be 5 years later, and 6 years later, and 7, 8, 9, 10, 11, 12, 13, 14, 15. Remember with Netflix, we chose T to be years after 2009. So we pick a convenient year, and sometimes the convenient year is the first year we're given, but sometimes we do something like an easier number like 2000, years after 2000. That's easy to count. Right? I can just look at a year and say, 2011, that's 11 years later, right after 2000. So my points then are 5, 7.35, and the other point would be 15, 9.47. And I want to find the line going through those 2 points. So the procedure we developed before was to find the slope first. So M is change in Y, 9.47 minus 7.35. Divided by change in X. So that would be 15 minus 5. Denominator is easy, numerator is not. I'm going to throw this into a calculator. Make a note to myself, 9.47, 7.35. All right, calculator. Let's use Desmos. Desmos is nice for things like that because you can say, hey, I got a fraction, and then just type your numbers. Numerator is 9.47 minus 7.35. And then denominator is 15 minus 5. And in one shot, I get a slope of 0.212. So we now have M. 0.212 what? Oh, good question. Let's see, my numerator, those were minimum wage dollars. So these numbers here are dollars, and these numbers here are years. So my slope would then be minimum wage dollars per year. So 0.212, that's around 20 cents. So what we can say is in Washington between 2005 and 2015, minimum wage was increasing by about 20 cents per year, would be a good sentence for that one. Minimum wage is increasing by about 20 cents per year, $0.2. Now we want an equation. I like y equals mx plus b. Instead of a y, they want us to use a w. We just calculated m as 0.212. Instead of an x, we're using a t. And then we got to figure out what b is. So b is the starting value. What does starting value mean? That means what is the point 0, b? Do we have a t equals 0 in the table? The answer is no. So we got to find it. We do that by plugging in one of the points. So I'm going to plug in my first point. the W for my first point is 7.35. And the T for my first point was 5. So all I have to do is do this multiplication and then subtract it over to the other side, and I got my answer. So I got to figure out what is 7.35 minus this product, 0.212 times 5. And that right there is my B. Calculator. All right, so 7.35 minus the slope, 0.212 times 5. And so I'm getting 6.29 for the y-intercept. So B is 6.29. And then if I hold a piece of paper up to those points on my screen through the first and the last, does it seem reasonable that we hit a little above $6? And yeah, that looks good. And I'm going to use my digital pen to try and show that here. So I'm going to start at the last point. You do this by holding a piece of paper up to your screen, pass through that first point and see where you hit the axis. And yeah, it's pretty darn close. That looks like a reasonable answer on this picture. And this was computer generated as opposed to my hand-drawn one, which is a little sloppy last time. Thanks, Macy, for that chat. Appreciate it. All right, so we have a line. We think for this situation right here with T years, whoa, it's not a pen, with T years after 2000, that the equation should be W equals 0.212 T plus 6.29. So that's our model for minimum wage. Now, when can I use that? Well, my data is only from 2005 to 2015. So this is definitely a model for those years. Can I use that model to ask what might the minimum wage have been back in 2000? Yes and no. I don't actually have that data, so this is just a guess. And then could I use that to predict what minimum wage is in, say, 2020 or 2021 or 2025? The answer is, well, yeah, I could, but I'm predicting the future there, which is a very tricky thing. So when we do make predictions like this, it's safe to use the equation to predict within the given data. So what that means is it's safe to use this to predict minimum wage in Washington State for the time period from 2005 to 2015. When you make a prediction within the given data, that's called interpolation. So to interpolate is to make a prediction with your equation within the range of the data. Right, interpolate. When you try to use your model to predict outside of the range of the data, that's called extrapolation. So if I were to use the model to predict for some year less than 2005, that would be an extrapolation with this model, this equation. And if I used it beyond 2015, that also would be an extrapolation. So to extrapolate means to predict outside the given information. Is it safe to extrapolate? A little bit. If your line is pretty tight to the points, you can go a little ways either side, but you don't really know what's going to happen in the future. You can just make a guess. So it would be an educated guess. All right, let's look back at our work. So we've gone over that, interpreting what the equation tells you. I'm going to leave that to you. Use the model to predict what's going on for 2020, 20 years after 2000. And then I'm going to actually help you with question number 7 here. So I'm going to jump down to question number 7. I'm going to give you guys some time to work and fill in the blanks in between. Question number 7 says, when does your model predict minimum wage would reach $15? Okay, if we continued with the same slope. So that means use this equation to figure out when it's 15. Let's try it. So our equation at the moment is W equals 0.212 T plus 6.29. And I want to know, when will minimum wage W be 15? So all I have to do is put a 15 there and solve. So 15 equals 0.212 T plus 2.9, 6.29, whoa, 6.29. So we've solved lots of equations like this before. We're going to do a subtraction first. Good idea to ask a calculator about that. So let's see, I'm just going to guess if we were to subtract 7, that would be 8.71, I think. I'm going to double check on the calculator. And then we're going to need to divide. But let's check that subtraction. So we had 15 minus 6.29. And that gives me 8.71, okay. And then we're gonna take that result and divide by our slope. So I'm gonna take that previous answer and divide it by my slope, 0.212. And I get about 41 for the answer there. So let's write this down. Last step, or second to last, 0.212 needs to be divided out. A number divided by itself is 1. 1 times t is t. Do the same thing on the other side. And I get that that is wavy equals approximately 41. T, remember, was years after 2000. So this would be in the year 2041. All right, so in the year, yep, got it. I will post this later. In the year 2041, we predict minimum wage in Washington State to be $15. And might as well say per hour, it's an hourly wage, just to be clear. So that's an interpretation of my calculation there. So my calculation came out to 41. I could double check that by plugging back in. Let's double check. So my equation was 0.212 times whatever number of years I plug in. I want to plug in 41. And then we had a y-intercept of 6.29. And that should give me about 15 years later. Now, notice it's not exactly 15. That's because I rounded this number down to 41 there. So I'm a little under, but it's close. So that checks. That's reasonable. All right, let's pause here.